Okay, so we're going to have a look at the electromagnetic spectrum. And before we do that, we need to think about what we mean by an electromagnetic wave and how it relates to something we already know. So let's go back to something straightforward, hopefully. So here's me on a summer's day. So there's the sun, there's me stood, and here's a football on the ground. I can see that football, and we need to think about why I'm able to see that football. Well, the reason is that there are rays of light coming from the sun. And those rays of light reflect or bounce off of the football and then into, so there's me and my eye, my nose, and then into my eye, not my nose there as it looks, but into my eye. So I can see the football because there is something coming out of the sun that is bouncing off of the football, and then that light ray is coming into my eye. So we need to think about what that thing coming out of the sun is. And it's actually this. Electromagnetic radiation. And actually we can call it, we can give it another name, and we can say that it is the visible electromagnetic radiation, and there's other types as well. So there is visible electromagnetic radiation travelling from the sun to the football, that then bounces off of the football into my eye, and I can see the football. And that's how I can see anything. Light bounces off an object into our eyes, our brain interprets that, and then we can work out what it is that we're seeing. Electromagnetic radiation travels as waves, and we'll do a lot more work on this in the future, but it travels as electromagnetic waves. So we've seen visible electromagnetic radiation, and we can actually break that into some more parts, the different colours of the visible part of the visible light: red, orange, yellow, green, blue, indigo and violet. So those are the colours that we would see in a rainbow. And there are other parts to either of this type of radiation to either side of this visible part of radiation. And if we go in this direction first, the first one we get to is ultraviolet, because it's beyond the violet part of the spectrum. And then we get to something called X-rays, and then right up at here we get to gamma rays. If we go the other side of our visible electromagnetic radiation, we get infrared, microwaves and radio waves. And all of these are electromagnetic radiation. And because there are 7 different types on the way, all the way up from radio waves up to gamma rays, we call this a spectrum. So this is the spectrum of electromagnetic radiation. All of these have uses, and we're going to see that in future lessons. Radio waves we use for communication and radar. Microwaves we use for cooking, but also that's how mobile phone signals pass. Infrared heats us up. It's also used in some television remote controls. Visible light is used in optical fibre communication. Ultraviolet is what causes us to have a suntan. X-rays are used in medicine in order for us to be able to see bones, and gamma rays are used in treating people with very aggressive cancers in radiotherapy. And we're going to see in the future about all of these uses. You might want to make a note of some of them now. So there are some things that we need to know about how they're different to each other. So gamma rays have a very high frequency. If they have a high frequency, that means they have a very short wavelength. So gamma rays are lots and lots of very, very small waves bunched up together, and lots of them will pass the same point per second. Because of that, that means they have got a very high energy. Very high energy indeed. Gamma rays, whilst they can be used to treat cancers, aren't very good for us, and that's why it's one of the last treatments that we would use if we're trying to treat someone with a cancer. If we go back down to the other end with radio waves, the opposite is true. Radio waves have a very low frequency. They have a very long wavelength, which means they have low energy. Radio waves, which are also used in Bluetooth, don't really cause any problems if they interact with us. And what we see is, as we move through the spectrum, then the frequency increases, the wavelength decreases, and the energy increases. So, just to review what we've looked at, we started by looking at visible light, and we said that visible light was a type of electromagnetic radiation. There are other types of electromagnetic radiation either side of visible light: infrared, microwaves, radio waves, and the other side, ultraviolet, X-rays and gamma rays. As we move through the spectrum, the frequency increases, the wavelength decreases, and the energy increases, which means that gamma rays and X-rays, and also to some extent ultraviolet, are actually so high energy that they can cause problems to human beings if they interact with us too much. Thank you very much.